Hello and hi all. Today we are going to discuss about aldol reaction. Aldol reaction can be of base catalyzed or acid catalyzed. In this video we are going to look at aldol reaction acid catalyzed version. As an example, we have taken acetaldehyde here. Acetaldehyde is reacting with another molecule of acetaldehyde in presence of an acid to form aldol. So this product is called aldol, as there is an aldehyde part and an alcohol part. So combining both those words together, we get aldol. So the product is called aldol, hence the reaction name is aldol reaction. Rather, it can be called as aldol addition reaction. Let us have a look at the mechanism, how the reaction works. So an aldehyde which has an alpha hydrogen, that's important, an alpha hydrogen is needed. First step of the mechanism is the protonation of the aldehyde. The two electrons on oxygen, the lone pair electron, is going to stay in between this oxygen and this hydrogen or H plus proton. So that is shown with this curved arrow. This arrow indicates that this electron is going to be in between this oxygen and H plus. Or in other words, the maximum probability of finding this electron is going to be in between this oxygen and this H plus. That means there is going to be a new bond. So this is the new bond. What is a bond? Bond is actually two electrons in between this two nuclei. That means in this case between this oxygen and this hydrogen. So the two electrons belonged to oxygen in the beginning, but now the two electron belongs to both this oxygen and hydrogen. Or in other words, we can say one electron belongs to oxygen, one electron belongs to hydrogen, which means oxygen lost one of its electron and hydrogen gained one electron. When a neutral species loses an electron, it will become positively charged species. And when the positively charged species gets an electron, it will become neutral. So oxygen is getting a positive charge here and hydrogen is becoming neutral. This charge is a formal charge. So to write formal charges, we need to consider these electrons as point objects, which they are not. But for our purpose, this is easy to think that way and it works. Once this gets protonated, in the next step, the alpha hydrogen is lost. So this oxygen is becoming more positive, which in turn has an effect on this alpha hydrogen. The molecule loses this alpha hydrogen as H plus and it will become an enol. This species is known as enol, as there is an alkene and alcohol part. Combining both those names, we have enol. Alkenes en and alcohols ol. Together, it is an enol. So this enol is formed from this species, this protonated aldehyde, by the loss of an H plus from alpha carbon. So now we have two species in equilibrium, which is the enol and the protonated version of aldehyde. Both these structures play an important role in the mechanism of this acid catalyzed aldol reaction or aldol addition reaction. So the reaction is going to be with this enol and with this protonated aldehyde. Look at this protonated aldehyde. This carbon, this carbonyl carbon is a positive center. As oxygen is electron negative, it pulls the electron towards it. So electron density is high on near oxygen and accordingly there is a loss of electron density from carbon. So carbon has a delta positive charge. But after protonation, oxygen gets a positive charge. So it more effectively pulls the electron towards it, and so the positive charge or delta positive charge of this carbonyl carbon increases. Or in other words, the positive center becomes even more positive. So this protonated aldehyde acts as the positive center or it acts as the electrophile. Now look at this enol. This enol can act as a nucleophile or can act as a negative center. How? This lone pair can result in a double bond here, C double bond. At the same time, this bond breaks and this attacks the carbonyl carbon. The 2 electrons in this bond will be responsible for the new bond between this carbonyl carbon and this carbon, this terminal carbon. As a new bond is forming, an old bond has to break. So, okay. So let us consider the 2 electrons which are going to be on oxygen. Now it is in the pi bond. 1 electron belongs to oxygen, 1 electron belongs to carbon. Both electrons are going towards oxygen. Oxygen is getting both electrons, that is oxygen's electron and this carbon's electron. So oxygen is getting an extra electron. So oxygen will be neutral. So this becomes oxygen neutral and this OH is neutral. Now in this case, in the case of carbon, this carbon, it loses an electron to oxygen, but it gains an electron in this bond, through this bond. So the formal charge of this carbonyl carbon atom will not change, as it loses 1 electron and gains 1 electron. So the 2 electrons in the pi bond is going to be here. So we can say this carbon loses an electron, but it gains an electron through this bond. The new bond gives an electron, while the old breaking of the old bond loses an electron. So because of the new bond, this carbon gains an electron, and because the old bond, the pi bond, broke, this carbon loses an electron. So it gains an electron, loses an electron. So the formal charge on this carbon is same, which is neutral. So here it is neutral. Now, how about this oxygen? The oxygen, both electrons are on oxygen. Now, once it's in a bond, 1 electron will belong to oxygen and the another electron will belong to this another nuclei, which is carbon. See, here a new bond is formed. In the new bond, 1 electron belongs to oxygen and 1 electron belongs to carbon. But both the electrons belonged to oxygen in the earlier case. So oxygen loses an electron. When a neutral species loses an electron, it will become positively charged. So it's like this. So the curved arrow is for the next step. The species is getting deprotonated to form our product aldol. So this is aldol addition reaction. So let's have a look at the reaction once again. An aldehyde is getting protonated, and the protonated aldehyde becomes an enol. This both are in equilibrium. Both will be in the reaction mixture, and the reaction will be between this enol and between this protonated aldehyde. The reaction happens in this fashion. A new carbon-carbon bond forms, and deprotonation will result in aldol. Now, if we let it go for a longer time, or this molecule can undergo another reaction if the condition favors and there is enough time. That is aldol condensation, which is known as aldol condensation. So the aldol product is protonated, as it's an acid. As the reaction happens in an acidic medium, this can get protonated, and which makes this species H2O plus, which is an extremely good leaving group. So it leaves in an E2 elimination happens. So a double bond forms here, then water molecule leaves. So that reaction, so the reaction is a condensation reaction. So it is called aldol condensation. Aldol condensation reaction is the whole reaction, meaning, so the whole reaction can be called as aldol condensation, where an aldol forms and then an water molecule eliminates from it. When the condition favors, this happens. Now, if there is no dehydration step, then we can no longer call it as aldol condensation. It will be simply aldol addition reaction, or we can say aldol reaction. Aldol addition reaction followed by a water elimination will result in aldol condensation reaction. Hope you understood the mechanism. And usually the aldehydes need not be the same. So the enol can be one aldehyde and the positively charged or positive center can be another aldehyde. Earlier, aldol reaction was performed in between two molecules of the same aldehyde. Later reactions were developed where aldehyde, the enol is enol and these protonated aldehydes are different. So we can manage that mixed aldol reaction. Not only aldehydes but ketones also do the same reaction. Even then, the product is called aldol and the reaction is called aldol addition or aldol reaction. Thank you and have a good day.